Hi class, today we're going to learn about section 2.8, Proving Angle Relationships. We are going to write proofs involving supplementary, complementary, right, and congruent angles. So before we jump into the proofs, we're going to review your different angle relationships. The first one is vertical angles. Remember that vertical angles are opposite angles formed by two intersecting lines. So those lines are going to form an X. In this example, angle 1 and angle 2 are vertical angles, and angle 4 and angle 3 are vertical angles. Remember that vertical angles are always congruent. Next, we have adjacent angles. Adjacent angles share a common side. So angle 1 and angle 2 share this side right here. Complementary angles are two angles whose measures add up to 90 degrees. So here you can see that angle 1 and angle 2 are adding up to 90 degrees. They do not have to be next to each other. They can also just be two separate angles, like a 30-degree angle and a 60-degree angle that add up to 90. And then finally we have supplementary angles, and those are angles that add up to 180. So here the two angles are forming a line. So this is a special pair of supplementary angles. This is called a linear pair. A line always equals 180, so linear pairs always add up to 180. But your angles could also be separate, where you could just have two random angles that add up to 180. For example, 30 and 150. Our first theorem is going to be the congruent supplements theorem. So this theorem says angles supplementary to the same angle or congruent to angles are congruent. So the way that you would write that with your notation, you would say angles supplementary to the same angle are congruent, or you could say angles supplementary to the same congruent angles are congruent. Here's an example. If the measure of angle 1 plus the measure of angle 2 is 180, and the measure of angle 2 plus the measure of angle 3 is 180, then you can say that angle 1 and angle 3 are congruent. Because each time you're adding 1 to angle 2 to get to that 180, and here you're adding 3 to angle 2 to get 180. So that means that these two would have to be the same, because obviously angle 2 would always be the same. The next one is the congruent complements theorem. This says angles complementary to the same angle or congruent to the same angle are congruent. Here's how you write it with shorthand. Our example says if you add angles 4 and 5 together, it adds up to 90. And if you add 5 and 6 together, it adds up to 90. So that means that angle 4 and angle 6 would be congruent. Try plugging in numbers to help you. Let's say 4 is 30 and 5 is 60. Well, if 5 is 60, then 6 would have to be 30 in order to add up to 90. So that's how you can see that 4 and 6 would be congruent. The next theorem has to deal with vertical angles. It's called the vertical angles theorem. If two angles are vertical angles, then they are congruent. Here's how you would write it in symbols. The last theorems we're going to go over are right angle theorems. So the first one says perpendicular lines intersect to form four right angles. So here's two perpendicular lines. It creates 1, 2, 3, 4 right angles. All right angles are congruent because they're all 90 degrees. Perpendicular lines form congruent adjacent angles. So these lines are forming four angles that are all 90 degrees, and they're next to each other. If two angles are congruent and supplementary, then each has to be a right angle. So congruent means they're the same. Supplementary means they're 180. So if two angles were the same and had to add up to 180, they would both have to be 90. And the last one says two congruent angles form a linear pair, then they're both right angles. Here's an example of that. 7 and 8 are a linear pair. They would both have to be right angles if they're congruent. The last thing we're going to talk about is the angle addition postulate. If D is the interior of angle ABC, then you can add the two smaller angles up to equal the whole angle ABC. So let's try an example. Find the measure of angle 1 if the measure of angle 2 is 56 and the measure of angle JKL is 145. So to do this, you would just need to subtract 56 from 145. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle JKL. And then you would plug in what you know and finally subtract the 56. Our last problem is actually doing a proof using this. So first you're going to plug in your given statement, given that the measure of ABC is 90. Then you can see they're using the angle addition postulate to add the two angles together and form the big angle ABC. The next step, we're using substitution because we're plugging in what ABD is equal to, what DBC is equal to, and what ABC is equal to. Then we're just solving an algebraic equation. We combine like terms, subtract 4 from both sides, and then finally divide by 2. That's all for today. All right, what's up?